Okay, in this example, I'm going to find the intersection of two planes, which before I start, I have to understand that if I intersect two planes, I'm going to get a line. So what I'm looking for is a line and not a point. Now, for this procedure, I'm much happier having my planes written in Cartesian form. So first thing, I'm just going to write this as 7x minus 4y plus 3z is minus 3, and call that equation 1. And this one as 4x plus 2y plus z is 4, call that equation 2. I'm also going to remind myself what I'm looking for. I know that the equation of a line in 3 dimensions looks something like this. X minus x naught over p is something to do with y's equals something to do with z's. So that's what I'm aiming for at the end of this process. So I've got to find a relationship between x's and the y's and then the x's and the z's. So to do that, I'm going to take these two equations and I'm going to eliminate variables in terms. First of all, I'm going to eliminate the y's. Eliminate y from 1 and 2. So what I'm going to do, I'm going to take equation 1, 7x minus 4y plus 3z is minus 3. I'm going to take two lots of equation 2, which is going to give me 8x plus 4y plus 2z is 8. I'm going to add those two equations to eliminate the y, which is going to give me 15x plus 5z is equal to 5, and I can then make that x equals, divide through by 5, rearrange, I'm going to get x is equal to 1 minus z over 3. So I've now got x in terms of z. Done. I'm now going to do a similar thing, but this time I'm going to eliminate the z. So here I'm going to take equation 1 again. 7x minus 4y plus 3z is minus 3. I'm going to have 3 lots of equation 2. 3 lots of equation 2 gives me 12x plus 6y's plus 3z's is equal to 12. What am I going to do? This time I'm going to subtract those equations. 12 minus 7, 5x, 6 minus 4, plus 10y. 12 minus 3 is 15. Again, divide through by 5, rearrange for x. X here is going to be 3 minus 2y. So what that gives me is now the information I need to write the equation. X is equal to 1 minus, so let's do the y's first of all. X is equal to 3 minus 2y is equal to 1 minus z all over 3. I can leave the answer like that. That will be fine. If I want to put it into standard form or turn it back into vector form, I'm going to go another step or two. I can rewrite it in the form given here by realising that x is just the same as x minus 0 over 1. 3 minus 2y is exactly the same as I need to divide each of these terms by minus 2. So I'll have y minus 3 over 2 divided by minus 1 over 2. And in this case, to make the z there, I need to divide each of these by minus 1. So z minus 1 over minus 3. That now enables me to write a vector equation, because I know that the position or the point on the line is going to be given by these values, 0, 3 over 2 and 1. and then the direction I know is given by the denominators. 1 minus a half minus 3. So there is my line of intersection, either in vector form or in Cartesian form.